Software testing, it can make your head spin because we have a lot of lingo in that industry, most of which sometimes people don't agree on terms, so it can be very confusing at times. So this video is essentially going to try to categorize different software testing technologies based on goal, on scope, on stimuli, and also on metrics. Basically, your software will have requirements being defined somewhere, somehow, even if it's only in the head of your developers. In other industries like avionics, then it needs to be something much more rigid, and fortunately, because you do want to go to the right places when you board a plane, right? Somehow, I don't think this is Florida. The FMS must have a bad day. So what is it? Simple. You give the software a certain set of commands, of inputs, and then you're expecting to have an output. And you try to see if it happens. If it happens, you pass the test. If it doesn't, you fail. Obviously, you want your software to do the right thing, but you also want it to do the right thing all the time reliably. Meaning that if you're going to stress it, or if you're going to give it some very, say, exotic type of data, then it's not going to do something funky. That's usually what we call robustness test. Other people may call it stress test. There's a slight difference in terms, of course. Sometimes it's going to be like giving really exotic values, as I said, or just to use it for hours on end and see if it's going to fail after 2 hours of continuous utilization. As an extension to robustness testing, there's also increasingly security testing, and we can understand why. Obviously, we have actors out there that are nefarious, and they want to know whether there's a way for them to penetrate your software and either make it crash or maybe even commandeer it. Well, that's evolving into a branch all on its own, and there are a lot of industries that before we only had quality standards, and now they're starting to have more and more security standards as well, because this is an emerging threat, especially with all of these softwares being increasingly connected, and in the case of devices or embedded software, being in a host of different locations. So it's very difficult to keep track on which systems are compromised or not. But here's another spin on that: performance, right? So for example, a company like SmartBear, they would have tools that enable you to test if your application that has a web interface is going to perform admirably under stressful circumstances. So I guess that somewhere it is stress testing, robustness testing certainly, but with a definite spin on, is it going to achieve the type of throughput that I'm trying to get. Another way to characterize software testing is scope. Obviously, there is going to be a phase where you're going to test the software in its entirety. If you're in embedded software, say for example in cars, that may involve actually placing the software in the device and then installing the device in the car and driving the car around to see if it fails. Like my friends that actually saw their heating system just go down because of a software problem in the middle of frigid Kansas. What are we going to do? I mean, this is bugged. Oh, I know it. I'm going to disconnect the battery. Reconnected? Now, understandably, people want to detect bugs way before they install it in the car, right? So that's why system tests is typically conducted first in the lab with specialized equipment hooked to a part and just test it to see like how it's going to behave once it's installed in the car. But it goes even further than that, because so far everything I described involved actually flashing the program into a device, and that's what we call black box tests usually. But you could also do white box tests, where you actually see the software behaving in real time in front of your eyes, right? And in that case, you can also isolate different parts of the software and test them individually. So it could be unit tests, usually test individual functions or individual classes. Sometimes integration tests, it's going to be many files, many functions working as a whole unit. So usually we call that integration test. So there's a lot of fine-tuning that you can do on your testing there. It depends on what people's objectives and also standards, frankly, recommend they do. Of course, you can make it a bit more complex by adopting your own scoping standards, right? So like automotive did. They often speak about SIL, PIL, and HIL, which means software in the loop. Usually, obviously, it would be a white box test of some kind. Then you will have processor in the loop, so you're executing the software onto the board, that is the computer that is going to run the software. And finally, HIL, which is the hardware in the loop, so in the complete system. Testing can also be classified through the types of stimuli that you give to the code. So, simple case, you're in front of your computer, you want to make sure that when you click a button, something happens. There are tools for that, like for example, Frog Logic, Squish, that will automate the clicking events that are necessary in order to trigger these behavior from your software. But say, for example, that you're doing unit tests. Well, you have direct access to the code. You're generating values directly straight into the code, right? You can do that by hand. There are frameworks out there that people use in multiple languages to do that. Or you can use a tool that is going to automate part of the process for you. So for example, Vector Software, or now I should say Vector Informatic, they have a tool called VectorCast that does exactly that in C, C++, and Ada. You have other companies like LDRA or Parasoft that do exactly the same thing. You also have things like the network test. Like again, Vector Informatic has a tool called Canoe that will actually send information through a network, and then you can monitor what is happening onto your board, into your software, to see if the behavior it displays is actually proper and correct. So obviously people are trying to automate the source of stimuli as much as they can, because time is money. But I see a lot of my previous clients that they did a lot of manual testing as well, because they know that sometimes human beings are the best way to break a software. And I even had a professor in university. He said that the way that he broke software was to give it to his young kids to play with. Well, I guess that can be a type of test too. People are going to usually do three different things. First, they're going to make sure that their requirements are being met. Whether the requirements are actually documented or not is another topic. I mean, it's certainly some people are doing better jobs than others, but at the very least, they want to make sure that the software does what it should be doing. The second thing is a set of KPIs about performance. Is that crashing all the time? So it's a whole set of metrics around robustness and like results from stress testing and performance. But the third one that many people use is code coverage. And here's the idea. If you have a line of code inside your software that is not tested when you're running all of your test cases, how do you know that this line is any good? So that's another way to make sure that your software testing is complete, so you can say that you're done and you can ship to your customers. Now, testing is not the only way that you can actually ensure code quality and software quality. There's another thing out there called static analysis. It's a way for you to analyze what the code is without executing it. Usually, the clients that I had the chance to work with, they're using both testing and static analysis. So in a future video, we should talk about static analysis.